This conversation is powered by Google Illuminate. Check out illuminate.google.com for more. Welcome to our discussion on open educational resources, specifically focusing on interactive physics simulations. We'll be examining two technical papers showcasing different aspects of online learning tools. The first paper details a standard HTTP response, while the second delves into a specific interactive simulation for secondary school physics. What immediately strikes you about the differences in these HTTP responses?
The key difference lies in the caching and security headers. The first response includes upgrade, H2H2C, suggesting support for faster HTTP/2, while the second uses transfer encoding, chunked, indicating a streaming response. More importantly, the second response includes a set cookie header, implying session management and potentially user authentication, which is absent in the first. This suggests the first might be serving static content, while the second is a dynamic web application.
That's a great observation. The second paper, as you mentioned, focuses on a specific interactive simulation. What are the core learning objectives of this tracker ball bounce model?
The simulation aims to enhance students' understanding of kinematics and dynamics through hands-on experience. Students analyze video footage of a bouncing ball using tracker software, allowing them to extract data and investigate concepts like velocity, acceleration, energy transformations, and the coefficient of restitution. It's designed to bridge the gap between theoretical concepts and real-world observations.
The use of tracker software is interesting. What are the advantages of using open source software like Tracker in educational settings?
Open source software like Tracker offers several advantages. Firstly, it's cost-effective, making it accessible to schools with limited budgets. Secondly, it promotes transparency and allows educators and students to understand the underlying algorithms and methodologies. Finally, the open source nature fosters collaboration and community development, leading to continuous improvement and expansion of its capabilities.
The second paper mentions several key physics concepts. Can you elaborate on the importance of understanding the coefficient of restitution in the context of this simulation?
The coefficient of restitution, COR, quantifies the elasticity of a collision. In the bouncing ball scenario, it represents the ratio of the ball's speed after the bounce to its speed before. A higher COR indicates a more elastic collision, meaning less energy is lost during the impact. Understanding COR helps students analyze the energy loss with each bounce and predict the ball's trajectory over time.
Let's shift our focus back to the HTTP responses. The first response includes several access control allow headers. What is the purpose of these headers?
These headers are crucial for implementing CORS, cross-origin resource sharing, allowing web pages from different domains to interact securely. Access control allow origin grants access from any origin, while access control allow methods and access control allow headers specify the allowed HTTP methods and headers, respectively. This is essential for modern web applications that often rely on data from multiple sources.
The second response includes several caching headers like cache control, no store, no cache. Why would these be important for a dynamic web application?
These headers ensure that the browser doesn't cache the response, forcing it to fetch the latest version from the server each time. This is crucial for dynamic content that changes frequently, such as user profiles, session data, or real-time updates. Caching an outdated version could lead to inconsistencies and errors.
The second paper also includes a section on short answer and essay questions related to the simulation. What is the pedagogical value of including such questions?
These questions serve as formative assessment tools, allowing students to test their understanding of the concepts explored in the simulation. The short answer questions focus on recalling key facts and applying basic principles, while the essay questions encourage deeper critical thinking and problem-solving skills. This combination helps reinforce learning and identify areas needing further attention.
The glossary of key terms in the second paper is quite comprehensive. Why is it important to define these terms clearly for students?
A clear definition of key terms ensures that students understand the concepts being discussed. Ambiguity in terminology can lead to misunderstandings and hinder learning. The glossary serves as a quick reference guide, allowing students to easily look up definitions and reinforce their understanding of the core concepts.
The FAQ section in the second paper addresses common questions about the simulation. What is the benefit of providing such a readily available resource?
The FAQ section proactively addresses common student queries, reducing the need for individual explanations and freeing up the teacher's time. It also empowers students to independently troubleshoot issues and learn at their own pace. This self-directed learning approach is crucial for fostering independent learning skills.
Second paper's website shows a vast collection of interactive resources. What are the broader implications of readily available, high-quality, open educational resources?
Readily available, high-quality OER promotes educational equity by making learning resources accessible to a wider audience regardless of socioeconomic background. It also fosters innovation and collaboration among educators, leading to the development of more engaging and effective learning materials. This can significantly improve the quality of education globally.
Looking back at both papers, what are some of the key technological considerations for developing and deploying effective online learning resources?
Key technological considerations include ensuring compatibility across different devices and browsers, optimizing for performance and speed, implementing robust security measures, and designing user-friendly interfaces. Accessibility features for students with disabilities are also crucial. Regular updates and maintenance are essential to ensure the long-term effectiveness of the resources.
Finally, what are future directions for research and development in this area of open educational resources and interactive simulations? This discussion has been incredibly insightful. Thank you for sharing your expertise on open educational resources and interactive physics simulations. The future of education is clearly intertwined with the development and effective use of such tools.